Yes, good morning, one and all. This is Balakrishna, assistant professor from Missouri University. Where I would like to discuss just the single interest. Uh, First, I'll give the definition for single interest, then we will go to implementation for the single interest. Single interest is a list. It is a collection of nodes. Each node contains a reference to the next node. What it means here, so here I'm take this is one node. So node contain data part as well as next node address. So that's if I'm taking here. So this is node. So here this is called as data part, and this one called as next node address. Yeah. So this is called no. First, before that linked list definition, just we need to learn what is meant by node. So node is a one type of data structure, one type of structure. It contains data part as well as next node address. This will be called as a node. Okay, here if I'm coming to linked list, the each and every node, this one is one node, this one is one node, this one is one node. Okay, these should be connected with some reference. That reference should be, so this is the address of the next contains the address of this one. Coming to here, this if it has some 1,000 memory locations, so here the next part contains 2,000. So here this has memory address is 2,000. So the next contains 3,000. So 3,000 is here. Okay. So the last node always contains null value. Why? Because there is no node. So that's why the next part contains null here. So always the head. So the head indicates your starting node address. What it means here? So head contains one address pointer only. So head always contains only address pointer, not the data. Okay, this should be refers the first node of your linked list. So this is regarding single linked list. That's why it has only single link. It should be only forward direction only, not reverse traversal or a backward direction also. Okay, here the head part contains here head also same like here in this way just here head also same here, but this head contains only the address of first node which is begins your list. Okay, always the last node, this is also called as the tail node. The tail node next should be null value. So in this way, say here the definition, the single linked list, each node contains a reference of the next node in the sequence. Traversing a single linked list to done in forward end. So what it means, the head points to first node and it should be in forward direction. In anywhere we are not using bidirectional or reverse direction. So it should be in forward direction only. So this is called a single linked list. This is called node. The node contains data part and the next node address. Clear? Okay. Here just we saw how to declare, how to create this node. Okay. So with the help of structure, we can create the node here. So for that, I'm writing here some logic. Just struct node. So what node contains? The node contains two parts. What is first one is data part, second one is next node address. Address always the pointer reference. Okay. Struct node. Okay. This we are taking you need to take any type of data. Here I'm taking integer type of, that is data part. Okay. Okay, what is the size of this one? So based on your, depends upon your compiler, it might be take 4 or 2 bytes. Here it will be take 4 bytes of memory. Okay. Next, node. So, node. State. Next. What is next here? Next is the pointer. So it might be take 2 bytes of memory. Every pointer occupies 2 bytes of memory only here. Okay. So next, the structure will be closed. Okay. So till now, just I'm creating one structure for node. Okay. Node contains data part as well as next node address. Okay. Okay. So this part is done. Okay. How the memory will be allocating for the node? How? So here, DMA concept is there, dynamic memory allocation. So it's in similar way, uh, we need to create one pointer here, that is pointer references like struct node space pointer new node. So here always we are trying to create one new node. So for that, this one be taking new node. If possible, you may initialize with a null value. No problem. Clear. How to allocate memory for this? How to allocate memory for this? For that, we have one statement. So new node. So this is for this new node, we need to allocate memory. For that, we have a malloc method, memory allocation method. For that, struct node. So we need to allocate memory for the node structure here. Struct node. It should be converting into pointer type. So malloc is using for malloc is using for allocating memory dynamically. A malloc, okay, in the size of struct node. Okay. So what will happen here in this statement? Here for new node, the memory will be allocated for, for new node. The memory will be allocated for 6 bytes. Why? Because the data part contains, what is it called? So data part plus next part. So this should be occupies 4 plus 2, 6 bytes of memory. Okay. Next, how to create this list here? So always the list should be starting with head node. So for that we need to take the help of one head pointer also. Clear? This I need to erase something from here. This one is done. Yes. Okay. Yes. So this will be executing in programmatically. So I, for that, just I'm entering, I'm taking one editor here, adjust. So before we saw on structure creation. So now I'm taking for insertion. So I'm create the list. Okay. So before that, we have one structure, struct node. In that we have in, sorry, the data part. Okay. Next, struct node. Next. So this one we completed. Next, struct node pointer new node is equal to null. Okay, this one is done. Now, so for creation, just we need to allocate memory for the new node. For that, I'm taking new node is equal. So first we need to allocate memory malloc size of struct node. Okay. So after that, this will be return the memory that should be converting or typecasting into pointer type. That's why I am taking it should be converting in pointer type struct node pointer. Okay, so this statement for typecasting of your allocated memory and storing into a pointer type. So new node is a pointer variable. Here we need to convert the memory to pointer and it should be assigned to new node. Okay. After that, just I need to create new node. So what are the steps here? So first, just we saw the steps. After that, we can implement the logic. Okay. So what we need to do here? First, I need to take a node here. So this is my node. Okay. Next, this contains here. So this is divided into two parts. Okay. So one is so this is called new node. Very first case, this is new node. Okay. New node. So here some memory is allocating for this. So that should be 1000 memories allocated regarding this statement. Okay, it has two parts. So very first case, what we need to do. So this data part is empty and as well as the next part also empty. So here the list always should be starting from head node. For that here I'm trying to take one head node pointer here. So just head node. So in that head node, I need to place my node starting address. What is the node? It has only now I was created only single node that contains 1000. That data, that address should be placing into this 1000. Okay. Now, actually, it is pointed to here. So just so this one is pointed to here. Okay. What it is? This called as head node. So always head node contains only address part, not any data part. Clear. Okay. So for that, just I'm trying to taking here. First, I need to take the data as single data. After that, I'm trying to implementing multiple. Okay. For that, here just we need to write printf enter data into list. Next, scanf percentile d comma ampersand. Here the data is contains in node. So the, the structure variable new node is created with the pointer reference. That's why we are using new node pointer data. Clear. Okay, new node data. So the reading part is done. Okay. So reading part is done immediately. So here what will happen? Here I am trying to take the data as 10. The first part is done. So very next case, what I need to do here? What I need to do? Just I need to write new node. So here the next node is not available. For that, just I am trying to placing the next value should be none. For that, I'm writing new node next is equal to null. Is this clear? New node next is null. Okay, new node next is null. Okay, what I'm trying to do here, immediately just I'm trying to write here null. Okay, okay, this is for this statement is accepting for only single node. If I'm trying to create one more node, so what will happen here? So if I'm trying to create one more node here, so this one is again I'm trying to take this one. So this is called what it called? Again, this one also called as new node. Why? Because we are allocating memory for that. Okay, new node as new node. Okay, the node is divided into two parts again. One is data part, second one is address part. So in that, just I'm trying to place the data as 20 here. The next two, similarly, the next is now. So regarding the statements, it will be here. But how I need to establish the link in between these two? This one has earlier new node. Now itself it is as a new node. It is a conflict one. Yes or no? Yes, obviously it will be typical. So further, just we are taking for avoiding this, we need to take the help of one more node that is called as temporary node. Here, just we are taking one temporary node here. Okay. So in temporary node, just we need to maintain one pointer. Okay, temporary also has. So this is called as temporary. Okay, temporary node. It also has. So, we are trying to maintain this one as one address part only. Further. Okay. Okay, here temporary, just we are trying to take very first. Head is the starting one. The new node, the link is established in between head and here. So just the 1000 should be copied here. Okay. So just I'm writing here. This one is the temporary. And so this one should be. I need to copy the 1000 here. Okay, 1000 here. Okay. So for that here, just I need to create one more pointer. So here one more pointer. What is that pointer? Temporary. So this should be also initially null value. Okay. So next, what we need to do here? So enter data into list, new node, the data should be added into that one. Clear. Data should be added into that one. Okay, but how now here one thing is happened. So now from here, the 1000 is pointed to here also. So head and temporary both should be pointed to single. Okay, head and clear. So yes, what we need to do here. Okay, so next is null. Immediately, what we need to check here. Very first case, we need to check if head is temp is or else head is null. Head is null in the sense this case it should be empty list. This should be empty list. Okay. So at that case, what we need to do? Head is equal temp is equal new node. So what will happen here? So earlier here, the new node contained here, the 1000 memory is allocated for new node here. Okay. Now here, both should be applied. Head is equal, temp is equal, 1000. It is clear. So here the head and temp both should be pointed to same node, that is new node. Okay. So now what we need to do here? Okay. Or else if it is empty, it is okay. Otherwise, it has, if it is has any elements else for, if contains any elements, any one elements in the list. If it contains any elements in the list, what we need to do here? What we need to do here? So the temporary is just moving to new node. Okay, just what we need to do here, temp, okay, temp next. Here. So what is the temp next? The temp is pointed here. Now onwards, this will be calling it as, so now onwards, this will be calling it as temporary node. Why? Because if the temporary is assigned to here, the temp next, obviously the temp next earlier null. Now just we are trying to assign the temp next is equal new node. What is the new node? So again, here we are trying to creating one node. So it has some address. That is the address 2000. Okay. Now, what will happen here? The null is replacing with 2000. Okay. Now what will happen? Just establishing the link to here. Clear. Okay. This one is temp. What we need to do? Again, my temporary is moving from here to here. Okay. That's why I need to add one more statement here. Temp is equal new node. So earlier, what is the temporary value here? Earlier, what is the value temporary? 1000. So what is the new node again? So if has already one data is existed, okay, it will be executed second time. What will happen? The new node is equal 2000 in second time. Okay, here the new node has 2000. Okay, now temporary is equal, temp is equal 2000 is still. Okay, just I need to replace this 2000 with 2000. Clear. So what we need to do here now, here from here, the link is destroying. Okay, just the link is establishing with the temporary to here, but the head always should be pointed to your starting of the list. Clear. So the temporary just it is moving from here to next node. Okay. So anything else here? So this will be clear. So why? Because here obviously just we are writing here earlier the new node next is equal, the null is as it is. If I'm trying to add one more node here, the temporary is moving from here to here, the next is null. It's so on, go on. Obviously the end node should be null. It is clear. So this one, this code is for creating your list, just creating the single linked list. Okay, next one. Just I need to display. So how to display? So again, here just we need to utilize the temporary. Okay. Here, just if I'm trying to check if head is null or tail or temporary is null. So the list is empty. Printf list is empty. Okay. Next, else what we need to do here? Just we need to display the form. Okay. Printf printf data tolerance percentile d link comma temp data data. So after that, just we need to move. So always very first case, the temporary is pointed to here. Very first case here, the temporary is moving to it is pointed to here. What is the temp data? Data is 10. That should be printing. After that, I need to move my temporary to this one. For that, I need to use temp is equal temporary next. Here, temp is equal. What is the temporary next? 2000. The 2000 is the address of next now. Okay. So further, just here I am trying to assign after printing immediately. Just I need to write here temp is equal temp next. Okay. So for our understanding purpose, the list should be L printf identifying the list ends null space slash. Clear. Okay. So this one is done. Okay. Coming to here, just here, if I'm trying to execute this one, this code will be applicable for only single node creation. Clear. So first let me execute. After that, what will happen? Let me check. Clear. So further here, just I'm trying to take main method for calling create function as well as display function. Okay. Just I need to save what I need to save here. Single list dot c. Clear. So just I'm trying to execute this form. Customer. So before that, just we need to add header files. Slash include stdibort.h hash std.h. Okay, this here we not declared any head pointer, comma, head pointer. It is also null. Okay, here enter the data into the list 10. So the 10 should be displayed. Okay. Our code is applicable for only single node creation. Okay. So it is I need to take multiple nodes to creating here. So for that, it should be iterative process. So I am placing in this one as iterative process. That for that, I'm taking one index value as well as one size. Okay. So printf enter how many nodes to create scanf percentile d comma ampersand n. Clear? So, so this process is repeating. For that, I am taking one iterative statement. It is simple iterative statement for loop for I equals 0, I less than n, I plus plus. So this should be facing in okay, inside the loop. Okay, from where up to the else part should be inside that. Okay. Okay. Again, I need to execute this one. Okay. How many nodes to create? I'm trying to create 5 nodes, 10, 20, 30, 40, 50. So only the 50 is then. Why? Because so here I think one statement is missing here. What is the statement? Just we need to write temp is equal head. Head is starting point. So that's why it will be from starting. The 5, 10, 20, 30, 40. So again, it should be displaying and what will happen here. When the list is empty, also 10 data, 10 to equal 10 next. It is equal 10, 10. So this one also repetitive process. So further just while and from where to where I need to display from starting to end. How to identify the end? The end node next should be null. So always this be part the temporary is moving from starting node to end node. Okay. So for that I am trying to write temp not equal to null, temp not equal to null, or temp next to not equal to also null, temp not equal to null. So the data should be printing. So for that it should be in. Again, it is a repetitive process. For that, just we are placing inside the loop. Okay, 5, 10, 20, 30, 40. Okay, so in this way, just we need to create the single linked list, okay, as well as uh, display. So both should be completing here. Thank you, one and all.